Thank you very much for the privilege again, and welcome to our next clip as we continue with our mathematical series. Now, here in this class, we're still going to continue with logarithms, laws of logarithms. Laws of logarithms. Laws of logarithms. Now, in our previous class, we have introduced what logarithms are, and where we saw that life was beautiful. And before we concluded in our previous class, we tried to state a law, and call it case 1, where we say the log of the product is equal to the sum of the logs, where we got an expression of this kind, a of xy, we said is equal to a of x plus the log in base a of y, where we said this simply means the log of the product is equal to the sum of the logs. Now, in this class, let's consider case 2. Now, given that we have x equal to a raised to power b, where a, b, c are real numbers, and let's also give that y is equal to a raised to power c. Now, this is in terms of indices. We have said that we can rewrite this in terms of logarithms. And in doing that, we said the this power is called the logarithm of the number of days in base this. So we say b here is the logarithm of this number x in base a. In like manner, this other one, we can also have this power, which is the logarithm of this number y in base a, this kind of expression. Now, in getting to this point, we multiply these two terms before we got this time. In this case, in the second case, let's try to take the division of this term, these two terms. Let's divide these two terms to see how the system will look like. Now, if we say x divided by y, then invariably we are saying dividing this by this. So we say a raised to power b divided by a raised to power c. And in our laws of indices, we say if the bases are the same and the operator in between is division, that we should subtract the powers. So this we can also write as b minus c, where we have x divided by y. Now, if you look at this critically, you can see that this x here is this term, a here is the base here, the b here we have it in terms of b minus c. So we can write this expression in terms of logarithm. Now, if we want to do that, this simply implies this power, which is the logarithm b minus c, which is the logarithm of in base a of this number, which is this minus this minus this. But in our previous class, you can see that this expression here, this side is in terms of b and c, whereas this side is in terms of logarithm. So let's try to see if we can write everything in terms of log, like this on the left hand side also in terms of log. And in our first expression, we have that b is equal to this and c is equal to this. So if we try to substitute all that into here, we are going to have the log for b, we have in base a of x, minus for c, we have the log in base a of y, all equal to log of a, this divided by this. So you can now see that we have now gotten an expression that also looks like this. So if we want to do that, then we can then write it here as our second case as log base a, x divided by y is equal to this of x minus the log of a of y. Why this thing simply means the log of the quotient is equal to the difference of the logs. The log of the quotient is equal to the difference of the log. Now, in a way, if you see an expression like this, note that you can also rewrite it in terms of this. If you are not comfortable with this, you can rewrite it in terms of this. Now, if you see an expression of this kind, you can also rewrite it in terms of this. Now, let's consider another case, say case 3. Let's consider another case, say case 3. And if we have x being equals to this, if we have x being equal to that, now this, let me click this part. If we have x equal to a raised to power b, then if we choose to multiply the powers by another number, say n, that is xn, then we are going to have a of b all into n. Now, from indices, if we have this kind of thing, we can multiply the powers as in this of this. Now, meaning that our xn here now is equal to a raised to power b of n. Now, getting to this point, if we try to express this thing, write this in terms of logarithm, this we can also do. This we can also do, where in this case this is the power. So we say bn is equal to the logarithm of this number, which is xn, in base a. In base a. This is what we have. This is what we have. But this expression as it is here, we are not comfortable with this, so we are going to rewrite this as n log of a of x. So in a way, we are saying that if you have a log where the number is raised to power something, then we should write it in terms of that power, the product of that power and the log of the number. That is, if we have a log in terms of that is expressed in terms of the power of something, we are saying that we are going to rewrite it in terms of that number, the product of that power and the log. This is what we have. So in a way, we are having bn is equal to n of log a of x. This is what we have. So in this case, if we have n here, and you take the log, we are saying that our bn will be equal to n of log a of log x. Let's consider another case, say case 4. Let's consider another case, say case 4. For that of case 4, in case we have, this is also powers of 0 as we were studying indices. If we have something like this, we have said that anything raised to power 0 is 1. Anything raised to power 0. Now we can also rewrite this in terms of logarithm. We can also rewrite this in terms of logarithm. Now, if we're doing that, we said the power, which is 0, is equal to the logarithm of the number 1 of a. So in this case here, you can say that the log of 1 to any base is equal to 0. The log of 1 to any base is equal to 0. The log of 1 to any base is equal to 0. So in that case, we're saying that if a is equal to 0, a raised to power 0 is equal to 1. Then in terms of log, we are saying that the log in any base, the log of 1 in any base is equal to 0, because this thing is the same thing as this. Let's consider another case. Say case 5. Let's consider another case. Say case 5. Case 5. Let's assume that it's not 0 now, but it's 1. A raised to power 1. A raised to power 1 means A in just one place, just one time, which is the same thing as A. A raised to power 1 is the same thing as A. And this you can also write in terms of logarithm. If we are doing that, we have said that the power here, which is 1, is equal to the logarithm in base A of that number A. So here in this case, the log of a number, and if that number is the same thing as the base, that the answer that we are going to have is 1. That is, if we have this, we are saying that the answer is A. This implies that the log of a number, which is A, where the base is itself that number, then the resulting answer is 1. The resulting answer is 1. Let's consider another case, say case 6. Let's consider another case. Say case 6. Let's consider another case, say case 6. In case 6, let's say we have the log of A of x. A of x. If we have this kind of expression, what do? If we can remember, in our case 3, we have been told that if we have the log in terms of, the log of a number, where the number is in terms of a power, that we are saying that is equal to the product of that power and the log. So in other words, this expression that we have can be rewritten as the product of that power, which is x, of log A of A. And we have been told in which of the case? In case 5, that if the log of a number where the number is the same thing as the base, then the resulting answer is 1. So invariably, this other part here is 1. This other part here is 1. So we have x multiplying 1. So this is equal to x. So what we are saying is that the log in base A of x is equal to x. This is case 6. Case 6. Case 6 says the log in base A of x is equal to x. Let's consider another case, say case 7. All these things are identities that you can use when going through simplifying some mathematical expressions. Now, if maybe we have, say, A, where it's raised to the logarithm of A of x. What do we do? What will be the resulting answer? We are saying that the resulting answer is x. The resulting answer here is x. How do we do that? This we can say, if that is to say, let this log x of A be equal to, say, b. Let's say that is equal to b. If that is true, let's try to see if we can take this thing here now is in terms of indices, where we have this base raised to the index of a number. So let's try to write it in terms of log to see how it will look like. If we want to write it, then this power here becomes this equal to the log or in base A of this number b. That is what we have. Now, looking at this, you see that this term here is the same thing as this term. So invariably, our b here is equal to x. So in place of this here, you can see we're going to say let this be equal to 2. So the resulting answer here is x. The resulting answer here is x. So what we are going to have in our case 6, we are saying that if we have an expression of this kind where it's raised to a log in this, then that the resulting answer is equal to x. That is our case 7. That is our case 7. We have other cases that we can also consider. We have other cases that we can also consider. Say maybe case 8. Let's call it case 8. Let's call it case 8. Where if we have this of this, we are saying that we can also rewrite this in terms of one all whole number, this of a. We can rewrite this as that. Now, how do we do that? How do we do that? This is also as simple as ABC. It's also as simple as ABC. So let's say if we have something like this, let's say if we have something like this, let's say let this log AB be equal to x. Let this log AB be equal to x. Then, if that is true, then we can rewrite this thing in terms of indices. Note that we have been changing from indices to logarithms. So this one already here is in terms of logarithm, so we can rewrite it in terms of indices. In doing that, note that this is the power, the index, this is the base, and this is the number. That is the number. This is what we have. So if that is true, then we can also rewrite this thing by eliminating this x and making just allowing it to stand on its own. If we want to do that, then this is simply dividing the power by 1 over x. If we do that, we're going to have a will be equal to b 1 all over x. So you can see that in this case here now, we have eliminated the x here and we have fixed it here back. This is it. Now, at this point here, what do? Let's try to rewrite this thing again in terms of logarithm as we have it here. Let's try to rewrite this thing in terms of logarithm. If we want to do that, this power now becomes 1 over x is equal to the logarithm of the number this, which is a, in base a. Now making x here the subject of the formula, we are going to have x inverting this one will come under cross multiply. We are going to have x will be equal to 1 all over log in base b of a. So we remember that we said let this entity be equal to x. So if this is this, then our x now becomes this. This is what we have here. So our case 8, we are saying that if we have the log of a number, say b of a, that we can rewrite this as 1 all whole number, 1 all over b of a, b of a. This is our case 8. If you have an expression of this kind, you can write it in this form. Or if you have an expression of this form, you can rewrite it in that form. Now there is another case which in this last case, we want us to maybe try it. Now it's also as simple as ABC. It's also as simple as ABC. These are just simple mathematical manipulations. With this one, if we are used to indices, it's also simple, pretty easy for us to manipulate. Now, for the ninth case, case 9, we have that if we have the log of a number, say x, that this can also be written as the log base a of x all over log in b of a. That is what we have done here now. Initially, you see that the base here is a, but the resulting answer here, you can see that the bases have changed from a to b, meaning that what we have here is just change in base. Change in base. So this is also straightforward to verify. This is also straightforward to verify. If you want to do that, it's as simple as ABC. Now, if we have this, let's say, as we have been doing, let this part here, a of x, is equal to, let's say, is equal to y. Is equal to y. If that is true, we can now rewrite this part in terms of indices. In terms of indices, we say this is the power here, this is the base, so we have a of y is equal to x. This is what we have. This is what we have. Now, from here, now what do? Let's try to take the logarithm in terms of their individual terms. Let's take the log in terms of their individual terms to a different base, say base b. Let's take this the log of these individual terms in base b. In doing that, we are going to have, say, log of x in base b, which is equal to log in base b of this entity, say y. But we have learned that when we have an expression like this, that we should multiply the power to the log. So this part can further be written as y, the log of b of a. Log of b of a. Now, if that is true, meaning that we have x of b is equal to y log of a in base b. So making y here the subject, because we said let this thing equal to y. So our interest is to determine the value of y. So we will cross multiply. If we divide through by this entity, we are going to have the log of x of b all over log of a of b equal to y. So if we plug the value of y, which is this entity, into this stuff here, we are going to have, if we plug that into this, if we plug the value of y, which is this entity, into this expression, then we are going to have log of x in base a is equal to y, which is our log of x of b all over log of a of b, which is the same expression as we have gotten. So what we just did is just change in base, where we took the log of these individual terms and you just simplify it and you see that everything is straightforward. So this is our case 9. If you see an expression like this, you can also rewrite it in terms of this. Or if you see an expression of this kind, you can also rewrite it in terms of this. Just by changing the base. Now, I will want to stop for the sake of this class. I will want to stop here. If you can remember, if you can go through, follow what we have done. Our first case here, which is laws of indices, we have said that the log of the product is equal to the sum of their logs, which we have. This is one case. Second case, we said the quotient, the log of the quotient is equal to the difference of the logs. Like here in this case, what we just did, in case you have an expression where the log of a number, where the number is raised to power something, we are saying that you multiply the power by that log. That is what we have. This is another identity that we have. Case 4, we said anything raised to power 0 is equal to 1. Therefore, the log of 1 of any base is equal to 0. If we try to write this in terms of log, this is what we're going to have. Case 5 here, a raised to power 1 is equal to a. A times a multiplying itself, just a in one place is a. So if you write this in terms of 1, meaning that the log of a number, where that number is written as a base, then the resulting answer will be 1. For that of case 6, we have said that the log of a number raised to power this is equal to that power, which is also similar to this that we have done. Is also similar. Where we try to use some identity when we were simplifying it. For that of the case 7, if we have an expression of this case where the power itself is log, then the resulting answer is this. For case 8, you can see if we have an expression of this kind, that you can also rewrite it in this kind. Case 9, this is what we have. Now, all that we need to do now is to follow through some examples to see how we can apply all these that we have studied. And this we are going to do in our next class. For the sake of this class, I thank you very much for your patience and your attention. But please try as much as you can to click on the subscription button as we look forward to having the other class as we continue with solving some live questions that will enable us to understand this concept properly. Thank you very much.